Okay, we're going to go ahead and find the derivative of the square root function now, which is kind of an interesting one to work. We've worked something like it already. Okay? But before we do so, I want to pause and say, what is the domain of the square root function? 0 to infinity, and what do you mean by 0 to infinity?
Non-negative numbers.
Yeah? Okay, that works. So we're going to include 0 then. Okay? Because can I take the square root of 0? Oh boy, you betcha. Right? What's the square root of 0? 0. Okay? All right, now let's go ahead and find f prime of x. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, which is the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Cassie, help me out. What's my next move?
Both sides counterpart.
Yeah. So we've got some square roots, right? And here's the real picture, right? We want to cancel out this factor of h in the denominator, right? Well, what are we going to cancel it with? Probably with this h that's up there, right? But this h up there is trapped inside of a square root, so we need to free it somehow. So the way we could do that is by getting rid of the radicals in the numerator, which we do by multiplying by the conjugate over itself. So here we go. As Cassie said, the square root of x plus h plus the square root of x all over the square root of x plus h plus the square root of x. This should seem a little bit familiar, folks. There's some repetition in these problems, right? Which is why in the next section we're going to develop some general rules to speed this up. Okay, but for right now, you're getting comfortable with using the limit definition. Limit as h approaches 0 of x plus h minus x all over h times x, square root of x plus h plus the square root of x. Doing a couple steps at once, folks. In fact, we talked about this last time. I'm going to add out the x's and then divide out the h's, right? So that will leave me with 1 over the square root of x plus h plus the square root of x. And now I can evaluate that to direct substitution. We get 1 over the square root of x plus 0 plus the square root of x, which gives me 1 over 2 square root of x. All right, did we answer my question? Well, we found f prime of x. What were we supposed to do then? Yeah, what is the domain of f prime of x? 0 to infinity.
But not including 0.
Yeah. Specifically, what am I saying here? The derivative does not exist where? At x equals 0. Does the derivative always have to exist? No. Sure enough, I mean, you cannot evaluate this expression at 0. By the way, the picture that sort of helps to justify that, if you've got any room left, if not, that's okay. The picture that sort of helps to justify that is, there's your square root curve, right? All along here, I can compute slopes of tangent lines, right? But at 0, what is the slope of that tangent line? Oh, it's a vertical line. What do we say vertical lines have a slope of? Remember this, going all the way back to Algebra 1? Vertical lines have an
Infinite.
Undefined slope, I think is what we said. Right? The slope of a vertical line we said was undefined. Right? That fits with what we're doing with our derivatives. Where you have a vertical tangent line, the derivative does not exist. All right, so what conclusion can we make from this? I think we could say that the domain of f prime is always a subset of the domain of f. Okay. Now, in some cases, that subset will be the same set. meaning the derivative will always be defined on the same set or a smaller set than the original function. That's what I'm saying there.